Assalamualaikum. My name is Alia Sulamiti Mazlan, and my thesis title is Synthesis and Characterization of Mesopotamian Carbonated Hydroxyapatite from Different Calcium Sources. And my supervisor is Dr. Naufalahiyah Muhammad. And now we'll continue my presentation with the introduction. So, Mesopotamian nanoparticles have unique features that make them suitable for nanocarriers. And carbonated hydroxyapatite is a plantation material for reconstructive surgery to cure bone defects caused by trauma or intensive surgery, since its chemical and phase composition is similar to that of the inorganic component of natural bone tissue. And the non-stoichiometric variant of hydroxyapatite is carbonated hydroxyapatite. And this carbonate substitution indicates the structure has been shown to weaken the apatite structure and make it more soluble. And it has also shown that it has better biocompatibility, bioactivity, and resorbability compared to hydroxyapatite. And next is my problem statement for this thesis is I found that in the previous study, synthesizing of only hydroxyapatite are weak to serve effectively as a natural human bone because of its low degradation rate and slow in generating a new bone. And next is the major problem in hydroxyapatite is caused by the low porosity of the HA. And I found that a better alternative, which is synthesizing mesoporous CHA from different calcium sources, need to be tested so that a data can be seen for the efficacy of this mesoporous CHA for various applications. And I will continue with the objective. So the first objective is to synthesize mesoporous CHA using the wet precipitation method with three different calcium sources, which is calcium nitrate tetrahydride, calcium chloride, calcium hydroxide, and phosphate sources is the ammonium hydrogen phosphate with the addition of ammonium bicarbonate. And next is to investigate the effect different sources of calcium on physicochemical and XRD on material characteristic and pore properties of the mesoporous CHA. And lastly is to investigate in vitro bioactivity of mesoporous char and synthesize from different calcium in phosphate buffer saline. And for the scope, is the first one is to synthesize mesoporous char using the wet precipitation method with the three different calcium sources. And second is the to identification of synthesis sample using X-ray diffraction or XRD for their phases and crystallographic structure. And third is to analyze using the Fourier transform infrared FTIR for the identification of functional group that represent CHE. And next is to analyze using the field emission scanning electron microscopy, which is FESEM, for the morphological and shape of the sample. And fifth is nitrogen adsorption desorption. It is to evaluate the surface area and the pore characteristic of the sample. And lastly is phosphate buffer saline solution test. It is to conduct in the vitro bioactivity to evaluate the capability of the mesoporous char to induce biological activity in biological environment. Next is my literature review. So, based on my literature review, I found that most of the journal articles are using similar method, which is the precipitation method, hydrothermal method, and the Solter method. As for the characterization, all journal articles are using the same characterized, which is XRD, FESEM, and FTIR. And all of the outcome from the journal are quite similar too, which is to find the effect of the mesoporous char for various reasons, such as for the drug delivery process and the implant applications. So lastly, I will continue my presentation for methodology. So in my methodology, these are the flowchart for the preparation of mesoporous carbonated hydroxyapatite, which is mesochar. And to begin with, the sulfated calcium ion containing solution are made by dissolving 3 grams of P123 in 100 milliliters DI water, and then adding 9.5 grams of calcium sources After that, mixture must be stirred up for 30 minutes. And next, 3.17 gram of phosphate sauces then will be dissolved in 60 ml DI water to make the phosphate ion sauce. Second, while stirring, the phosphate solution mixture and the surfactant calcium solution will be titrated until the milky solution will be formed. And the milky solution alkalinity was kept constant at pH 11, and the milky solution will next be aged in an oven for 24 hours at 120 Celsius degree. Finally, the solution will be cooled down and centrifuged for 10 minutes at 3000 rpm to get all the white precipitate. And finally, the excessive surfactant was washed and centrifuged for 5 times with the DI water to eliminate it from the precipitate. The white precipitate must next be dried in an oven at 100 degrees Celsius for a whole day. And this dry precipitate was then crushed to produce fine powder using a crusher or pestle or mortar before being incinerated for 6 hours at 550 degrees Celsius. And then we'll be going through to the last stages, which is powder characterization. Go through SRD, FTIR, FESEM, and BET. And then after getting the mesophyll structure powder will be the end result of my synthesis. Thank you. That's all from me.